CAR-T Foundation, and we are working in collaboration with Valladolid University, near to Salamanca. I am in the robotics and artificial vision area, and in this area we are working on mobile robotics and social robotics. This is a work for a specific project, a big project who is going to be a robot to be in a hotel environment, a service robot for hotels as a bellboy. So I'm going to show you our outline. I'm going to be quickly because I have less time. I'm going to show you a review how we organize the knowledge of our agent in its memory. Then I'm going to show you how we modeling the agent in a game, and then some results and conclusions. Okay, basically, why we are doing this? Why we need social robotics? Basically because the average of the people, we have more older people, we have to get tools to service this kind of people, and also because we are always want to know how we interact, and because of that we have to imitate our cognitive system, what our cognitive system does. And our cognitive system is responsible for this kind of capabilities that is what we are going to imitate in our agent. Capabilities like communication, coordination, adaptation to novel situation, and learning through experience. So, as we can see in the picture, that's what we want for the future. Basically, a service robot that can safely coexist with us, communicate, and successfully cooperate with us. Basically, we model our agent in a prototype because we want in our group have a prototype to test our approaches, our investigation. We are working on different technologies like vision technologies, recognition, speech recognition technologies, path planning, so we need a prototype to prove. We are based on some works that were doing the same like us, like SOAR. SOAR is a known architecture for a cognitive system for modeling intelligent system. In this work, they model the behavior of a non-player character, like could be Mario, and they put in them reinforcement learning to enhance his behavior through experience. There's another work more closer to us, and this is a model of the behavior of a tank pilot in a wartime game. So they model the different components of the game, like chase, like when to attack some other tank, and stuff like that. So, what we are going to do? We choose SOAR because it's an important architecture and give us this type of representation of the knowledge. SOAR works with different types of knowledge, and he organized this knowledge into types of memory. I'm going to show you them. And for the modeling the game, we use XNA, a Microsoft software that brings us the code, the specific code for the game. So we only have to worry about what we really need about the game. So SOAR. Okay, in SOAR we have two types of memory. The working memory of the current situations and the long-term memory. In the long-term memory we have different types of memory, the procedural. In the procedural memory we have the knowledge about how and when to do things, like how to ride a bicycle. In the semantic knowledge we have the facts that are real for our agent, that are real for its own universe. And the episode we have the knowledge of basic instance in the past. So this is what we are going to model in our agent.